Hello, in this video we are going to look at 5a and 5b from the Rational Expressions worksheet. Now this worksheet looked at how do we deal with rational expressions, and it drew on some exponent laws, and we did things like rationalizing the denominator. Now all of a sudden you see the scientific notation, and for a split second you think this is not what this is not the same theme, but it is. So let's take 5a, and I'm going to rewrite it so it looks slightly different. I'm going to rewrite it like this. So all I've done is I've taken the scientific notation, and instead of writing 10 to the 3, which is right here, and 10 to the 5, which is right there, I've just replaced those 10s with x's. And this simply becomes an exponent law question. So we see we're multiplying them together. We have the common base of x, so we add our exponents. So we get 25 x to the power of 2, because negative 3 plus 5 is 2. And if you can do that, you can do this exact same question. So 10 times 2.5 is 25 times 10 squared. And there we go. So, and this is the disconnect. Often when students get into scientific notation, they don't make that connection that essentially you can apply all your exponent laws here in the same way. Now, this question asks you to write your answer to two significant figures, and that is a whole set of videos unto itself. So I will say that this case, we are already in two significant figures. One really easy way to think about it is if you write out your answer in scientific notation, if you move the decimal to the right-hand side, you can read off your significant figures rather easily. So let's look at this next example here. So I'm going to just do the same thing I did last time. I'm going to rewrite this as 0.2 over 4x to the 7. Again, I'm going to apply my exponent laws. So we get 3.28 x cubed over 4x to the 7. And 3.28 divided by 4 is 0.82. X. 3 minus 7 is minus 4. Now what I'm going to do in this case is I'm going to rewrite this and change the scientific notation slightly. But let's come back up here and let's do this again. So again, I see I have scientific notation 10 to the negative 3, 10 to the 6. So my first step is going to have 3.28 times 10 to the power of 3 over 4 times 10 to the 7, which gives me 0.82 times 10 to the minus 4. And I'm going to rewrite this as 82 times 10. And if I'm moving my decimal, 1, 2 times 10 to the negative 6. And I'm done. You could write this as 8.2 times 10 to the negative 5, and that's perfectly acceptable as well. I hope this video helped, and if you have any questions, don't hesitate to ask.